Hello, this is Mrs. Dubois, and I'm going to go over the answers. I think I am. Hi, this is Mrs. Dubois again. Anyway, I'm going to go over the answer key for practice 4. We're going to exploring graphing lines below. And we're connecting this back to our visual, algebraic, and numeric models that we have seen in the past, the beginning of the year. The first great rule of problem solving is that you read a problem carefully. So the first one says you have $100 in an account and you're going to add $5 each week. We want to find the total amount of money in the bank account. So if we draw our visual, you're starting with $100 in the bank, and then each week you're going to add 5. And then if we wanted to numerically calculate what we have each week, on when we start saving, which is 0, our initial value is 100. And then each week, we should put dots because this can go on forever and ever, we're going to add $5. And our pattern is an increase of 5. If we want to write it algebraically, if you notice the pattern is an increase of 5, that would be your slope, 5x, and then your initial value is that you started with 100, okay? So this is a positive value, this coefficient on x, so it is an increasing, all right? And it crosses the y-axis where the initial value starts at 0, 100. Problem number 2, the temperature of a hot water is 150 degrees Fahrenheit. It is cooling down at a rate of 3 degrees per minute on average. We want to find the temperature after each minute. So again, if we want to draw a picture, we're starting with 150 degrees. That's our initial value. And then the temperature is decreasing by 3 each time. And then we can go to our numeric value. So our initial value, or where we start, is 150, and then it is decreasing, so our pattern is to subtract 3 each time. All right, and if now we want to translate that into the algebraic model, again, we go to the 150, which is our initial value, and the pattern is going down 3 each time. So our slope, or the coefficient in front of the x, is minus 3, okay? So because this value, or the coefficient in front of the x, is negative, it is a decreasing. You could put that on Desmos too and see that it was a decreasing graph or a decreasing line. And the initial value, or where it crosses the y-axis, is 150. Problem number 3, you are selling t-shirts and charge $15 per shirt. We want to find the total cost per shirt. So if I'm going to draw that, the initial value here is actually 0, so we don't need to draw that. And then every shirt we buy is $15. And again, we can put 3 dots here because we don't necessarily know how many t-shirts we're buying. So the initial value is 0, right? Because if we don't sell any shirts, then we don't make any money. And each shirt is 15x. Now you can leave it like this, that's perfectly correct. Or if you just want to simplify it a little, you can write it as y equals 15x. If we move to the table, remember, no shirts, no money. If we sell 1 shirt, we make $15. If we sell 2 shirts, we make $30. So if we want to decide if it's increasing or decreasing, we notice that the coefficient in front of the x is positive, so it's increasing. And the initial value, like I said, is 0, 0, because if we don't sell any t-shirts, then we don't make any money. Now, what you want to do is put this first column, if you have any difficulties, into Desmos. Okay? And so the first one is done for us. this is y equals negative x plus 5, okay? Y is by itself on one side. So you can tell the slope of a graph, which is the coefficient in front of the x. It's often referred to as m. So the coefficient is -1, so m equals -1. Because the slope is negative, it's decreasing. B is the value at the end here. So that is 5. And then it hits the y-axis at 0, 5. And if you put that into decimals, you will in fact see that it hits at 0, 5. For this one, again, it's in the form that called function form, that y is by itself. The m is the coefficient in front of the x, so it's -2. Because it's negative, it is decreasing. And then the b value is -1, which means it hits the y-axis at 0, -1. For the next one, it's the same form. Y is by itself. So m is -2/3. It's negative, so it's decreasing. B is equal to -4, and then you have 0, -4. For this one, same format. Coefficient is +2/5. It's positive, so it's increasing. The b value is the constant out here. B is equal to -4. Therefore, it hits the y-axis at 0, -4. Okay. This one, the coefficient is -6. Therefore, the slope is -6. You can write it as -6/1. It's your choice. Because the slope is negative, it is decreasing. The b value is 0, and therefore it hits the axis at 0, 0. All right, we're looking at two things. To find the slope, it's the coefficient in front of x. It's positive, it's increasing. The b value is the coefficient at the end, -1. Therefore, it hits the y-axis at 0, -1. And you should see a pattern, right? In the top one, b is 5, and so the y-intercept is 0, 5. Second one, b is -1, and the y-intercept is 0, -1. Okay, then we can finish up. M is equal to -2. That makes it decreasing. B is equal to 4, and then the point of intersection on the y-axis is 0, 4. Now, if you've been putting these in Desmos to see whether they're increasing, decreasing, and where they hit the y-axis, you will, when you put this one into Desmos and this one into Desmos, you will notice that it makes a straight horizontal line. Okay, and we talk about patterns in math. And if you look up above, the pattern is that these equations have both a y and an x. And if you notice right here, this only has a y. And that's kind of like a bell going off that you either are going to have, you're going to have a constant line, which means it's going to be either straight horizontal or straight vertical. Now, y equals 6 is going to hit the y-axis. So the slope of this graph is 0. It's constant. It's going to actually, there's no b value really listed here, but it is going to hit at the y-axis at 0, 6. Same thing with y equals -2, okay? There's only one variable in this equation, so it's going to be, because it's y, it's going to be a horizontal. So the slope is 0. We call it a constant. And then it's going to hit the y-axis at 0, -2. And I'd strongly encourage you to bring that into Desmos so you can see the difference between the top 7 and the bottom 2. Okay, now that we're examining values and we're thinking about what's the slope and what's the b, Let's see if we can challenge ourselves and find the equation of the line of these graphs. Okay, so we have said that the coefficient in front of x is the slope. The first thing you want to do is take a look at the line. Now, I noticed that the slope of the line in this first graph is negative, okay? So you always want to make sure if it looks like a negative slope that you have a negative slope in your equation. Now, we're going to go up and over, okay? I like to pick a direct point, okay? And we're forming a right triangle, and you want to count the rise. 1, 2, 3, 4, 5, 6. So it's 6 up. And then the run, or going horizontally, is 2, all right? So the slope is rise over run, which is 6 over 2, or it reduces to 3 over 1. So we said it was negative, so it's a negative 3x plus, let's take a look at where this hits. It hits the y-axis right here, which is negative 3. So plus a negative 3. Okay. For number 2, you're thinking the same strategy. Okay, this is a negative slope, so I want to make sure I have a negative slope represented in my equation. Then I want to take a look at, I'm choosing 2 points that directly hit the line. The rise, which is 1, 2, 3, over the run, 1, 2, 3. Okay, and again, the slope is the rise over the run, which is 3 over 3, which is 1 over 1. And we can write it as 1 over 1x plus it hits the y at a positive 3, or we can also put it as y equals negative x plus 3 if we want to simplify it a bit. Either one is perfectly fine. Okay? So we're thinking the same thing when we get to the third one, but this one is a positive slope because it's increasing. Then we're picking 2 points, and we're going to examine the rise over the run. All right, so the rise is 1, 2, 3. I'm going to write that right here. Rise, run. Rise is 3. 1, 2, 3. The run is 3. That reduces to 1 over 1. We're in the same situation as we were with example 2. So we can just put this as x, 1 over 1x, or 1x. And then we want to examine where it hits, and it's right here, negative 3, where it hits the y-axis, okay? The last one, again, it has a positive slope. Sometimes maybe I even write it up here. And then if we're looking at where the 2 points, we want to count the rise over the run. So you rise up 1, 2, 3, and you run 1. Okay, so that gives us 3x, and then negative 2 is where it hits the x-axis. And there you go.